Hey YouTube, welcome back to another tutorial. In this one, I'm going to be teaching you all about the Pascal's triangle and how we can solve it using recursion. So I'm just going to go and get ahead into the problem, and then I'll explain a bit about recursion and how we're going to use recursion to solve this problem. So given an integer num rows, return the first num rows of Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it as shown. So here we have an example of Pascal's triangle. I'm sure most of you are already familiar with Pascal's triangle, but if you're not, we have ones along the edges of this pyramid, and inside the smaller pyramid right here, we get each value by adding the two numbers directly above it. So if this was 2, we'll add 1 and 1 to get 2. Pretty simple. If you need more explanation, I suggest you look into it, but let's move on. In this first example, our input is num rows equals 5, which is convenient, which is what's up here as well. And we're going to output a 2D array. And this 2D array is going to contain a list of arrays where each array is a row of Pascal's triangle. Similarly, if num rows is equal 1, we're going to output 1, but 1 is still going to be inside a 2D array. Now, our constraints are num rows is greater than or equal to 1, and num rows is less than or equal to 30. So, how do we use recursion to solve any problem? So the idea is to find a way of solving the overall problem by breaking it into smaller subproblems, such that some of the smaller subproblems can be solved using the same method as that used to solve the overall problem. The solutions to the subproblems are then combined to get the solution to the overall problem. So in our case, what we're going to do is we're going to find a way of solving one row in the array, and then we're going to repeat that process using recursion to solve all of the rows in the array. But what we're going to need is a base case. A base case is what's going to tell our function when to stop recursing. So we don't want this to keep going on indefinitely, so we need a spot to stop this recursion, and that's going to be our base case. So our base case is going to be if num rows is equal to 1, we're going to return 1 in a 2D array. And this is going to make more sense in a second. Well, let's get to our recursive call. I'm going to define prev_rows, and this is going to be our 2D array, which is going to store everything. And I'm going to say generate num rows minus 1. Now, what am I doing here? Now, this is our recursive call. So I'm going to pass num rows minus 1. So we have a process for every single row. What's a process? A process is just a line of execution. Let's say, for example, num rows equals 5, right? Num rows equals 5. Right here, we're passing 5. This is going to pass 4, then 3, then 2. Then when we reach 1, we don't want it to keep going. We don't want to call generate of -1. We don't want to call generate of 0. We don't want to call generate of -1. You can see how this loops indefinitely. So once we reach 1, we return our first 2D array, and the first value in that 2D array is going to be the first row of the pyramid. Now from here, all we need to do is push the new rows into this 2D array for each process that's running. So every process is going to push its row into this 2D array. So let's say one of our processes is running that isn't 1. So 5, 4, 3, 2, or 1. We're going to create a new row, which is a new array of size num rows, and we're going to fill this with 1. So what are we doing here? We're creating a new array of size num rows. Why is this of size num rows? If you're on row 4, there's going to be 4 elements. If you're on row 3, there's going to be 3 elements. That's one of the patterns you need to pick up on when you're doing a problem like this. You got to think, is there some piece of knowledge that I can use to make this solution easier for me? And we're filling this up with 1 as a placeholder, but the reason we're filling up with 1 and not a number like 0 is because we know that each row starts with the number 1 and ends with the number 1. We'll already have the first value filled and the last value filled correctly. So when we loop through each row to fill it up with the proper values, we'll know that the first element and the last element are already taken care of. So let's do that now. Let's loop through our new row and fill it up with the proper values. So how do we loop through this? I'll say for let I equals 1, And we're starting this off at 1 for the reason I just mentioned. We know the first element is going to be 1, so we don't have to loop through it. And then we're going to say while I is less than numRows, because there's numRows elements in each row, minus 1. Again, for the same reason as the first, we know the last element is going to be 1, which is correct. Now we're going to increment this loop. Now I'm going to set new row of I equal to prev_rows, an element in prev_rows, plus another element in prev_rows. And I'm going to leave these square brackets empty for now. So why am I doing this? Our new row is the row we're currently on. So what prev_rows does is it stores all of our previous rows, as the name implies. And now we need to access the row above our current row. And that's going to be numRows minus 2. Because if you can recall, the generate function was called on numRows minus 1. So numRows minus 2 will give us the row that is above our current row. And we'll do this for this prev_rows as well. But what is really going on here? This is actually the logic for adding the two numbers directly above the current number. Okay, so now that we've accessed the rows of the two numbers that are above the current number, we need to access the actual element. So we need to pinpoint which numbers we're going to be adding. And for this case, it's going to be I minus 1 and I. And the reason being, it really helps if I draw this out. Let's say we had 1 and 1, and then we had 1 blank and 1, and we're on this blank right here. This is the first index, which is I or 1. So to get the value of this index, you have to add I minus 1, which is 0, and I. So that's what we're doing here. But now we actually have to put this new row into our prev_rows array for the next recursive call. So I'll say prev_rows.push new row, and then I'm simply going to return prev_rows at the end here, and then we call return prev_rows to return the overall array. Now let's submit this and see if it worked. And you can see we passed all our test cases. This is going to have a time complexity and a space complexity of O of n squared. Now the reason being, for the time complexity, we're calling generate for every single one of numRows. And we also have this for loop of length numRows inside of the function. So O of n times O of n is going to give us O of n squared. Now for the space complexity, we have n number of rows, and we also have n number of elements for each row, so the space complexity is also going to be O of n squared. Now I hope this helped you guys out. If you have any questions, make sure to leave them in the comments. Like and subscribe if you want to support the channel, and that's going to be it. Thanks guys.